Hello students. In the previous class we have learned about degree measure and radian measure. Now today we will see how to change degree to radians, radians to degree, real numbers to radians, real numbers to degrees, all that. So if I want, I can measure the angle theta in many ways. First of all, I can write theta as 30 degrees. So this is degree measure. If I want, I can write it as pi by 6. This is radian measure. But if I want, I can write it as 2. This is in real numbers. So first of all, I will tell you how to change radian measure to degree measure. This is the easiest of all. But before doing this, we have to learn a few things. After this, I will tell you. So first thing you have to learn here is, you have to remember these things. 2 pi means 360 degrees. Pi means 180 degrees. Pi by 2 means 90 degrees. And 3 pi by 2 means 3 into 90 to 70. These are the basic things which you have to remember. Don't forget. Actually, you need not remember also. It is logic. 2 pi is 360 degrees means pi will be half of 360 degrees, 180. Pi by 2 means half of 180, that is 90. 3 pi by 2 means multiply pi by 2 by 3, 90 by 3. Very easy logic. Okay, now we will see how to change radian measure to degree measure. This is the first thing we are going to learn. Suppose you have 2 pi by 3. Then what you have to do is, in place of pi, you have to write 180 degrees by 3. 3 ones, 360s. So easily you got it 120 degrees. This is one way to change radian measure to degrees. But sometimes you will be given radian measure in real numbers. 6 radians. It's a real number. 6 is a real number. Then how will you change it to degrees? You have to multiply 6 by 180 degrees by pi. Then 6 into 180 will be 1080. Then pi you have to write as, remember, pi another value is 22 by 7. Pi can be written as 22 by 7. 22 by 7. So this will be 1080 into 7 by 22. Or this is nothing but 343 7 by 11 degrees. Because 2 11s. Then you will have 2 5s, 2 4s, zeros. Then you have to divide. This is what you will get. If you want, you can see 7 0, 7 4s 20, 8, 2, 7 5s 35, 37. You divide by 11, 11 3s 33, then 4, 8, 11 4s 44, 4 and 0, 11 3s 33, then 7. So 343 7 by 11. Like this you can write. And now if you want to simplify further, 343 degrees 7 by 11 degrees. Now this 7 by 11 degrees we will change it to minutes. To change it to minutes, 1 degree has 60 minutes. So you have to multiply 7 by 11 with 60 so that it will convert it into minutes. So 340 degrees, you will have 7642, which you will divide by 11. So what you'll have, 11 threes 33, 90, 11 eights 88, 2. So 38 2 by 11 minutes. This is what you have. Okay, now 343 degrees, 38 2 by 11 minutes. This all I'm doing to change radians to degree measure. So 343 degrees, 38 minutes, 2 by 11 minutes. Next, 343 degrees, 38 minutes, 2 by 11. If I want to change it to seconds, 1 minute has 60 seconds. So 2 by 11 you multiply by 60 so that it changes into seconds. 343 degrees, 38 minutes. Here we have 120 divided by 11. So 11 ones 11, 1 0. 11 zeros. So 0, put point, one more 0, 9, 99. So it can be written 10.9 seconds. Or you can round it up. 343 degrees, 38 minutes, 11 seconds. 6 radians we could convert it into degree measure. So sometimes radians will be like real numbers. That also you can change it into degree measure. The next we will learn is changing degree measure to radian measure. Suppose you are given 45 degrees. So to change it into radian measure, you have to multiply 45 by pi by 180. Always pi by 180. Previously, what did I say? You have to multiply by 180 by pi to change radians to degrees. Okay, so now 5 nines, 5 threes 15, 5 6, 9 ones, 9 fours. So it is pi by 4. Sometimes you may get difficult problems like 40 degrees 20 minutes. You have to change it to radian measure. Not that easy. So what you will do is 40 degrees 20 minutes also we will change it into degrees. How? Because 1 degree has 60 minutes. 1 minute has 1 by 60 degrees. That means I have to multiply 20 with 1 by 60 degrees. Or zeros will cancel, 2 ones, 2 threes. I can write 40 degrees and 1 over 3, 1 by 3 degrees. Or I can write 41 by 3 degrees. Or 121 by 3 degrees. To change it to radian measure, 121 by 3, I have to multiply by pi by 180. So that means I have 121 pi by 540 radians. This is how we can change degree measure, difficult one, to radians. Sometimes you will be given a radians in numbers, like 3 radians. It's a real number. But if you want pi, if you want pies, then what will you do? 3 radians, you have to change it into pies. So what we will do means, pi means 22 by 7 or pi means 3.14. So if you take 3, how will you change it in pies? 3 pi by 3.14. 3 pi by 3.14. Or multiply 100 up and 100 down. Or 2 15s and 0, 2 15s and 7. So 150 pi by 150. So different ways of conversion I am teaching. Okay, let's take some problems. You have to find the radius of the circle. The angle in the circle 60 degrees is given. The arc length is given as 37.4 centimeters. Pi you have to use as 22 by 7. You have to find the radius. That means there is a circle. We don't know the radius of the circle, but we know there is an arc length. Arc length is 37.4, and in the sector, the angle theta is 60 degrees. In the previous class, I told you one formula, L equal to R theta. So R is L by theta. L is 37.4. And theta, we will not write theta as 60 degrees. We have to change it to radians. So what will you do? You will multiply by pi by 180. 61 63s. So pi by 3. Theta is pi by 3. That means 37.4 into 3 by pi. But I had to measure the radius. So pi should not be there. So what I will do? Pi I will write 22 by 7. That means 37.4 into 3 into 7 by 22. Or I can write 2 11s, 2 18s, 36, 1, 2 7s. Then 11 ones, 11 ones, 11, 7. So 0.7. That means it is 21 into 1.7. Or 35.7 centimeters. This is how I could find the radius. Next, in a watch, the minute hand is 1.5 centimeters long. How far the tip moves in 40 minutes? So suppose the tip is moving till here. So in 40 minutes, this length of the arc you have to find. Length of the arc. Radius is 1.5 centimeters. In 40 minutes, what is the angle it moves? That we have to find. If you find theta, it will be easy to find the length of the arc. Suppose in watch, if you take the minute hand, from 12 to or from 0 to 1 to move, how many minutes it will take? It will take 5 minutes. From 1 to 2, it will take 5 minutes. From 2 to 3, 5 minutes. Like that, 2 to 3. 3 to 4, another 5 minutes. 4 to 5, another 5 minutes. 5 to 6, another 5 minutes. 6 to 7, 5 minutes. 7 to 8, 5 minutes. 8 to 9, 5 minutes. 9 to 10, another 5 minutes. 10 to 11, another 5 minutes. And 11 to 12, another 5 minutes. So to move one revolution, to make one revolution, how many minutes it will take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It will take 60 minutes. So 2 pi in 60 minutes. So 40 minutes it is moving. They said the hand is moving 40 minutes. So in 40 minutes, what is the angle? 2 pi into 40 by 60. 0 cancels, 2 ones, 2 threes. So the angle is 4 pi by 3. Theta is 4 pi by 3. Now length is r theta. R is 1.5. Theta is 4 pi by 3. 3 into 0.5. So 2 pi. But because we are finding the length, pi you can write as the 22 by 7, or you can take 3.14, anything. So 6.28 centimeters is the length of the arc. That means the tip has moved 6.28 centimeters in 40 minutes. So practically, if you are good at the concept, you need not think. You can do it very easy. If the arcs of same length in two circles, arc length, same length, two circles, subtend angle. Here the angle subtended is 65 degrees. And here the angle subtended is 110 degrees. Find the ratio of radii, R1 by R2 ratio. That is what you have to find. So we know that both the L's are same. And we have the formula L equal to R theta. So here L is R1 into 65 degrees. But 65 degrees, I will change it into radians. I will multiply by pi by 180. The other one, L equal to R2 theta, 110 degrees and multiplying by pi by 180. Now both the L's are same. So R1 into this I will cancel. 5 ones, 5 threes. 5 threes, 5 6. Here zeros and zeros will cancel. So I can say R1 into 13 pi by 36 equal to R2 into 11 pi by 18. 18 ones, 18 twos. I can cancel. Then both the sides I can cancel the pi also. So R1 by R2 will be 11 by 30. Or R1 is to R2 is 11 is to 30. I forgot the 2 here. So 22. 11 into 2. I'll rewrite this. I have R1 into 13 by 2 equal to R2 into 11. That's why I will have 22, not 11. This 2 I forgot. So with this, we can start exercise 3.1. 3.1 to total we have 7 questions. So we can try to complete these 7 questions today before the class ends. First question. Find the radian measure. So you have to change it to radian measure. First one, 25 degrees. Multiply 25 by pi by 180. 5 5s, 536. So it is 5 pi by 36 radians. Next, second question. Minus 47 degrees, 30 minutes. So minus 47 degrees. This 30 minutes, I have to multiply by 1 by 60 degrees. To change it into degrees, I have to multiply by 1 by. I told you why I have to multiply. Because 1 degree has 60 minutes. 1 minute you will write 1 by 60 degrees. That's why. Okay, 31s, 32s. So I have minus 47 and a half degrees. Or I can write this as, I can write 94 plus 1, 95 by 2 degrees. But still I did not change it to radian measure. I have to multiply this by pi by 180. To change it to radian measure, pi by 180. So when I cancel 5 ones, 5, 5 nines, 536. So I have minus 9 pi by 19 pi by 72 radians. Minus 19 pi by 72 radians. I have changed it into radian measure. Next, third one. 240 degrees. Multiply 240 degrees by pi by 180 degrees. So first 0 will cancel. 6 4s are 24, 6 3s. 4 pi by 3 radians. Next, fourth one. 520 degrees. 520 degrees multiply by pi by 180 degrees. 0 cancels. Then 2 2s, 2 6, 2 9s. So it is 26 pi by 9 radians. Total 7 questions. Already we completed 1 question. Second question, you have to find the degree measure for the given angles. First one, 11 by 16. 11 by 16, this is actually real number, but it is in radians. So I have to multiply with 180 by pi. 6 ones, 6 30s. Now 11 into 30, I will divide by 22 by 7. Because I'm changing it to degree measure. That means 11 into 30 into 7 by 22 degrees. 11 ones, 11 twos, and 2 15s. So I have 15 into 7. Oh, I made a mistake. Instead of writing 16, I wrote 6. So we will do from the beginning. 11 by 16 is a real number, but it is in radians. So 11 by 16, to change it into degree measure, I have to multiply by 180 degrees by pi. 2 8s, 2 9s and 0s. 2 4s, 2 45s. That means I have 11 into 45. In the numerator, I have 11 into 45. Denominator, I have 4 into pi is 22 by 7. Changed it into degrees. 11 into 45 by 4 into 7 by 22. Like this it will be. So I can cancel 11 ones, 11 twos. So 45 into 7 is 315 by 8 degrees. But this I can divide. 315 I can divide by 8. 8 3s 24. 7 and 5. 8 9 72. So 3. I can write this as 39 3 by 8 degrees. Or 39 degrees 3 by 8 degrees. 3 by 8 degrees I have to multiply by 60 to convert it into minutes. So 2 4s, 2 3s. 39 degrees 90 by 4. Still I can cancel. Instead of writing 90 by 4, I will try to simplify into lesser numbers. 2 2s, 2 15s. So 45 by 2 minutes. Or 39 degrees, 45 by 2. How can I change it? 45 by 2, I can divide. So 45 I'll divide by 2. 2 22s 44. So it is 22 and a half minutes. That means 39 degrees, 22 minutes and half minute. So half minute I will change by multiplying half into 60. I will change it to seconds. 39 degrees, 22 minutes and 30 seconds. This is how I will change. Okay, second question. In second question, minus 4. It's a real number, but I can write minus 4 radians. So to change it into degree measure, I have to multiply by 180 degree by pi. And then pi I will write 22 by 7. Now cancel. 2 2s, 2 11s. That means I have 180 into 2 into 7. Right? So that will be minus 2520 by 11 degrees. I can divide 2520 by 11. 11 2s 22. 3 2. 11 2s 22. 1 and 0. Bring 0 again. 11 9s 99. 1. So I can write this as minus 229 1 by 11 degrees. Now minus 229 degrees 1 by 11 I can multiply with 60 to convert it into minutes. So minus 299 degrees 60 you have to divide by 11. 11 5s 55. So it changes to 5 by 11 minutes. Or minus 229 degrees, 5 minutes. 5 by 11 minutes you can multiply by 60 to convert it into seconds. So minus 229 degrees, 5 minutes. 300 you will divide by 11. 11 2s 22. 11 7 77. So I can change it as 27 3 by 11 seconds. (27) 3 by 11 seconds. And I can round it up. Minus 229 degrees, 5 minutes and 27 seconds. Okay. Next. Third one. 5 pi by 3 is already in radians. So pi I will write 180 degrees by 3. 3 ones, 3 6. So I get 300 degrees. Fourth one. 7 pi by 6 is in radians. 7 into 180 degrees by 6. 6 ones, 6 threes and 0. 210 degrees. Okay, next. This is question 3. Total we have 7 questions. A wheel makes 160 revolutions in 1 minute. How many radians does it turn in 1 second? So, first of all, one revolution means 2 pi radians. 360 revolutions it is making. 720 pi radians. It has moved 720 pi radians. One revolution means 2 pi radians. So 360 revolutions means 720 pi radians. This much distance, this is the distance the wheel has moved in 1 minute. That means it has moved 720 pi radians in 1 minute means 60 seconds. So in 1 second it will move 720 pi by 60 radians. These two cancels. So how you can write this? 236, 2 threes, 3 ones, 3 12s. So it has moved 12 pi radians in 1 second. This is second. In 1 second. They're asking you the angle it has moved in radians. How many radians? This is how you will get the answer. Okay, question number 4. Find the degree measure of the angle. Find degree measure of angle subtended at the center. The circle's radius is 100 centimeters. Radius is 100 centimeters. And the length of the arc 22 centimeters. So we know L is equal to R theta. L is 22, R is 100, we have theta. Theta equal to 22 by 100, that is 11 by 50. This 11 by 50 only is the angle, but we have to change it to degree measure. So you have to multiply by 180 degrees by pi. So 0 and 0 will cancel. 11 into 18 degrees by 5 into pi can be written as 22 by 7. Pi. So this by 7 I have taken up. 22 by 7. By 7 I have written up. So 11 ones, 11 twos, 2 ones, 2 nines. 63 by 5 degrees. Or 63 I will divide by 5. 5 12 63. So I have 12 3 by 5 degrees. 12 degrees 3 by 5 degrees. 3 by 5 I have to multiply by 60 so that I can convert it to minutes. 5 ones, 5 twelves. So it is 12 degrees 36 minutes. We need not do it in seconds now. Next. Fifth question. In a circle, the diameter is 40 centimeters. That means radius is 20 centimeters. So if you take radius 20 centimeters, 20 centimeters. The length of the chord, suppose this is the chord. The length of this chord is 20 centimeters. Find the length of the minor arc. That means you have to find this length. First of all, you can see this triangle is equilateral triangle because all the sides are 20, 20, 20. And we know in equilateral triangle, the angle will be 60. Every angle of this triangle will be 60. But I have taken only one. Okay, theta is 60 degrees. So on the whole, I have to find the length of the arc. L is r theta, that is 20 into 60 degrees. Convert 60 degrees. So 20 degrees, you have 20 into 60 degrees, right? So first 60 degrees, I will convert it into radian measure. How? Multiply 60 degrees by pi by 180. 60 once, 60 threes. 20 into pi by 3. Now, you can keep it as it is or you can change it to decimals. Changing it to decimals means lot of calculation. So this is the length of the arc, minor arc. Next, question number 6. There are two circles. The radius of the first circle is R1. The radius of the second circle is R2. Okay, now we have arcs of same length. In this circle, this is the arc we will take. In this circle, This is the arc, same length. Here length is L, here length is L. So this arc subtends an angle 60 degrees in the first circle, and in the second circle it subtends an angle 75 degrees. Find the ratio of the radii, R1 by R2. This is what we do. So we will use L is equal to R theta. L equal to R1 into 60 degrees. L equal to R2 into 75 degrees. R1 into 60 degrees I will multiply by pi by 180. Equated to R2, 75 degrees also I will multiply by pi by 180. Or R1 by R2 will be equal to 75 into pi by 180. 75 into pi by 180 by 60 into pi by 180. First of all, pi by 180 will cancel. 5 15s, 5 12s, 3 5s, 3 4s. So R1 by R2 we got 5 by 4. In the question, they asked us to find the ratio of R1 to R2. And we got R1 is to R2 as 5 is to 4. Now we can move on to the next question and the last question of this exercise. That is the 7th question. In 7th question, find the angle in radian measure through which a pendulum swings. If its length is 75 centimeters and the tip describes an arc of length. There are 3 cases: arc length 10 centimeters, arc length 15 centimeters, arc length 21 centimeters. So imagine this is the point, and from this point the pendulum will swing like this. And this is the distance the pendulum moves, or this is the arc the pendulum makes. The length of the arc, we will take it as L. And now this is looking actually like a sector of a circle. I did not draw the full circle. I have drawn only sector of the circle. So this will be the radius of the circle. The length of the pendulum itself is the radius. length of the pendulum is 75 centimeters. Radius of the circle is 75 centimeters. Now, for the first one, length of the arc is 10 centimeters. Radius is 75 centimeters. You have to find theta in radian. So L equal to R theta. 10 equal to 75 theta. Theta is 10 by 75. 5 twos, 5 15s. So theta we got 2 by 15. It's a real number, but we can call it as radians. In the second one, same. R is, radius is 75 centimeters, theta we don't know. But the length of the arc is 15 centimeters. So L equal to R theta, 15 equal to 75 theta. Theta is 15 by 75. 5 ones, 15 ones, 15 fives. So theta is 1 by 5 radians. With 15 you can cancel that. For the third one, R is the same, 75 centimeters. But the length of the arc is 21 centimeters. You have to find theta. So L is equal to R theta. 21 equal to 75 theta. Theta equal to 21 by 75. 3 sevens, 3 25s. So theta is 7 by 25 radians. So with this we have completed exercise 3.1. Now we have to go to the theory part or the concept part of the next topic so that we can do 3.2 exercise. Already in 10th class, you have learnt about trigonometric ratios. I will remind you that. You have taken a right angle triangle, name it as ABC. If you take angle theta here, the side AC is the opposite side. The side BC is adjacent side for theta, and the hypotenuse of the triangle is AB. So total there are 6 trigonometric ratios: sin theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. To write this ratio, you will write sin theta as opposite side by hypotenuse. Opposite by hypotenuse. Cosecant theta will be reciprocal of that. That is hypotenuse by opposite. Hypotenuse by opposite. Just reciprocal. Cos theta is adjacent side by hypotenuse. Adjacent by hypotenuse. Secant theta is reciprocal of cos theta. That is, it will be hypotenuse by adjacent. Tan theta is opposite by adjacent. Opposite by adjacent. Cot theta is reciprocal of that. Adjacent by opposite. So these are the 6 trigonometric ratios. You can remember like this. Sin theta starting with S is opposite by hypotenuse. Opposite by hypotenuse. So, cos theta starting with C is adjacent by hypotenuse. Ka. Tan theta starting with T is opposite by adjacent. Opposite by adjacent. So you can remember like this. So, ka, toa. If you remember this, you can remember sine, cos, tan. With that you will remember cosecant, secant and cot. So just now I told you cosecant theta and right here. Cosecant theta is reciprocal of sine theta. Sine theta is reciprocal of cosecant theta. And when you multiply sine theta and cosecant theta, you will get. Then I told you secant theta is reciprocal of cos theta. Cos theta is reciprocal of sine theta. I will write here. Cos theta is reciprocal of secant theta. The color of the ink has changed. And then when you multiply cos theta and secant theta, you get. Then cot theta is reciprocal of tan theta. Tan theta is reciprocal of cot theta. When you multiply tan theta and cot theta, you will get. Not only that, tan theta is sine theta by cos theta. Because tan theta is opposite by hypotenuse. Cos theta is adjacent by hypotenuse. So opposite by hypotenuse is multiplied to reciprocal. Hypotenuse by adjacent. And so you get tan theta as opposite by adjacent. That's why tan theta can be written as sine theta by cos theta. Cot theta is the reciprocal of tan theta, so just take the reciprocal. Cos theta by sine. These all you have already learned in 10th class. But now we will not deal with trigonometric ratios. We will deal with trigonometric functions as a function. As a function means I have to tell you in a diagrammatic way. We will take x-axis, we will take y-axis, and then with center at origin and the radius as 1. Here also 1. Here -1. Here -1. I will draw a circle. Because the radius is 1, this is called a unit circle. Now I will take any point. Let us take a different color. I will take any point on the circle with x coordinate A, y coordinate. That means if I draw perpendicular here, this distance is A and this distance is 1. And this is radius of the circle 1. If I take the angle here in the triangle as x, So first thing I can write here is sine x is b by r. Cosecant x is r by b. Cos x is a by r. Secant x is r by a. Tan x is b by a. Cot x is a by b. First of all, I have to write this. Then by Pythagoras theorem, I can write a square plus b square is r square. Or a square plus b square is 1. Because radius is 1. Now, from this I will write b is r sin x. And because r, the radius is 1, b is sin x. From this I will write a is r cos x. Because the radius is 1, r is just cos x. Radius is 1, so a will be cos x. Instead of a, I can write cos x and square it. Instead of b, I can write sin x and square it. So cos x, when you square, it will become cos square x. Remember this. Here many of you may have chance to make a mistake. And sin x whole square can be written as sin square x. That means cos square x plus sin square x is 1. X can be any angle. Cos square x plus sin square x will be 1. I will tell you more about the angles when we go to the next class. Now just trigonometric functions we have started. These are called functions: sin x, cosine x, tan x, cot x, secant x, cosecant x, trigonometric functions. We will learn about many more things in trigonometry. Be perfect with whatever you have already learned. We will end the class now.